Okay, let's go over this, see how you did. By the way, I'm recording again, so if you are not here today, you can watch this on the shared folder. It should be there after this class, right next to yesterday's lesson that I know you all went home and watched again with your parents. Okay. So it says evaluate without a calculator. That's in cursive. Someone last period couldn't read the first word, and it was because it's written in cursive, and my cursive especially, which is not the best penmanship, but oh well. How do we read that? 4 times 3 halves, is that right? Thank you. 4 to the power of 3 halves, or 4 to the 3 halves power, right? Okay, so one of the things that we're going to be learning, or reviewing, I should say, because you have already learned it, is going over exponents that are not just nice natural numbers like 1, 2, 3, 4, 5, but rather exponents that are rational numbers, mainly fractions, and possibly integers, like negative numbers as well, or even negative fractions, oh my, okay? So 3 halves is what as a decimal? 1.5. It's 1.5, okay? So let's think about where this answer should live. Like if this were a multiple choice question and you didn't have a calculator, you might be able to eliminate some answer choices based upon some other information if you don't know the right answer. If 3 halves is 1.5, 1.5 is between 1 and 2. So what would 4 to the first power be? 4, okay? What would 4 squared be? 16. Therefore, the actual answer should live somewhere between 4 and 16, right? So if you have any answer choices that are outside that range, you're like, not today, donuts, or whatever, because it's going to be a very attractive looking answer, like donuts. And maybe you get it down to like 2 answers that live between 4 and 16, and then you're like, okay, I'm just going to flip a coin, heads or tails on this one. Now, when you have a coin and you're going to flip it to call heads or tails, how do you know whether you're going to pick heads or tails? You get out another coin and you're like, heads, I pick heads, tails. Okay. Anyway, does anyone have the answer? 8, 8. What's that? Oh, that's a question mark? So that's like 8 question mark? Oh, okay. Is that 6 exclamation point? Or just a question mark? 8? Okay, if this were a democracy, and of course math is, right? We have 2 votes for 8 and 1 vote for 6. 3 votes for 8. 8, 8, 8. Wow, oh my gosh. 8, 6. All right. Bernie Sanders is coming back strong. 8. 32. There's the dark horse candidate. 10. All right. All right. Let's see what the answer is, okay? Are y'all ready? Fractional exponents. Let's come off to the side here and review a little bit. If we have something like that, that's how do we read that? Square root of x. So there is an implied what number right there? 2, okay? That's called the root index, by the way. The root index. You're going to be learning new vocabulary, new terminology, and you're going to be eradicating bad behavior that you've been picking up over the years that your previous math teachers have let slide, okay? That's the root index. It's implied to be a 2. We can rewrite that as x to the 1/2 power, okay? Not x squared, but x to the 1/2 power. You could think of it like this, okay? Think of like 1/2 like this. Here's the ground, right? Here's the ground. Oop, I'm running out of room. There's the ground. The 1 is above ground, like where the flowers would be, right? And if this is the ground, guess where the 2 is? It's underground where the whats are? Where the roots are, okay? That should help you remember then that the root index, which is underground where the roots are, goes in the denominator of the exponent, okay? Now, you've already seen that before, so this is review. What if it were this, the cube root of x? I can write that as x to the what? 1/3 power. What about the 4th root of x? That's the same as x to the 1/4, so on and so forth. You got it? Yes, you have it. Good. So let us come over here and see if we can apply that. 4 to the 3 halves, that's the same as 4 cubed to the 1/2 power, is it not? We saw that rule yesterday. When you raise a power to a power, that's exponentiation, it turns into what? Multiplication. And what is 3 times a half? 3 halves. Very good. Okay? So those rules we can always use in reverse. Usually we're going this way, right? We see 4 to the 3rd raised to the half, and we're going to go ahead and multiply those to get 4 to the 3 halves. But we can also decompose it the other way. Ew, gross, decompose. Hey, that reminds me of a composer joke. I find it kind of funny. I find it kind of funny, and you might too, that Mozart spent his entire life composing, and his entire afterlife decomposing. Okay, nice. So let's go ahead now and use that rule. 4 cubed to the 1/2 is now the square root of 4 cubed. Yes, yes? I only know 2 composer jokes. That's one of them. Okay. Now, what is 4 cubed, everybody?
64.
How'd you get that so fast? Did it come to you, or did you have to like work it out in your head, like 4 times 4? Oh, you did? Okay. Yeah, I did too. I had to go like 4 times 4 is 16, and then I went 16 times 4, and I'm like, I can't do that in my head. So I came over here and I went old school, 16 times 4, carry the 2. Is that how y'all did it? Or did you just know 4 cubed was 64? No? Okay. Yeah, you had to do that. Okay, sweet. All right. So that means it's the square root of 64. And now you're like, oh, that's just what? 8. Yeah. So the answer is 8. So congratulations, those who got 8, and well run campaign to the losers. Okay. Now, because we did not have a calculator, we made the 4 bigger to become 64, only to do what at the end? Make it smaller. Now, when you have a calculator, the calculator doesn't care if you make numbers big and then make them small. But if you're doing it without a calculator, going big and then going small might be a little bit challenging. Okay? So, let me ask you this. Is multiplication commutative? What does commutative mean? You drive to school as a commuter, you drive back home as a commuter in the afternoon. Commuting means back and forth, back and forth. So the commutative property of multiplication is what I'm asking if it's true. It's basically asking, is 2 times 3 the same as 3 times 2? And the answer is yeah, right? Just like addition, it's commutative. So what if I took this line right here, 4 cubed to the 1/2, and instead I wrote it as 4 to the 1/2 cubed? Would that be equivalent?
Yes.
It is. Because what's 1/2 times 3? 3 halves. And what's 3 times 1/2? 3 halves. Multiplication is commutative. Does that matter in the way we work this problem? Let's see. The way I have it written now, 4 to the 1/2 becomes the square root of 4, and then I cube that result. Now, what's the square root of 4? 2. Did you have to think about that one?
Yes.
Maybe a little bit, maybe not much at all. Because the square root of 4 is easy. There's nothing to compute. It's 2. So that becomes 2 cubed. Now what's 2 cubed? 8. Which was easier without a calculator? Going big and then going small? Or going small and then going big? Go small, then go big. Yeah. There's 2 benefits to that. When you go small, then big, you're making the numbers much more manageable for yourself, okay? And then the other added benefit is you're ending on a big note, right? Which is always good. End on a big note. You're going big at the end. So you're not only learning how to do stuff in here, they're both correct. Both methods are correct, but you're also learning to find strategies that work better, okay? And that's a strategy. Go small before you go big when you're working with numbers. Take roots before you raise them to power. Try to divide before you multiply. Try to subtract before you add. It's a philosophy. It's an efficient philosophy. Okay? Got it? All right. So that's your warm-up. Are y'all warm? I want you to be just the right kind of warm so that you don't pull a math muscle. I do not want you working math cold, okay, because you're going to cramp up. And I don't want you overheating either. I don't want you to be too warm. Okay? It's just like it's like the oven right before you put in those Totino's pizza rolls, right? You want it to be sufficiently warm so that it toasts those pizza rolls to perfection. Now, truthfully, guys and girls, how many of y'all, when you're making those Totino's pizza rolls, it says preheat oven to whatever? How many of y'all just go ahead and throw them on the pan, just put it in the cold oven and then set the timer and walk away? No one wants to admit to that. I do that because I'm impatient. I'm not going to stand here and wait for the oven to preheat just to put in the pizza rolls. I got other things to do, right? Those Netflix series don't watch themselves. I don't want to have to get back up. Okay? Most of y'all wait for it to be preheated. You set a timer for preheating and then you come back and then put them in? Oh, it beeps when it's ready. You got a fancy one. Nice. Let me give you a tip. Here's a hint. Okay? Here's a hint. Oh man, I got vertigo looking at your shoes, dude. Whoa. Okay. Here's a hint. Put the oven on, but put it on broil or 500 degrees. What? Yeah. Just hang with me for a little bit. Then you take them pizza rolls and you put them on a microwavable safe plate. Okay? A big plate because you're going to want a lot of them. While that oven is heating up to broil, lava hot, you pop those things in the microwave for about 2.5 minutes. You don't want to put them in there for like 3 to 4 because then they pop and all the goodness flows out. You don't want that. Just get them like sufficiently warm, like a warm-up, okay? And then you take them out and then you put them in the oven, which is on broil, for just another 2 or 3 minutes. The microwave heats them up, kind of makes them a little bit what? Mushy. You don't want mushy pizza. But then you put them in the oven that's at 500, and what does that do? It crisps them up, right? Like putting a shirt in the dryer on a cold morning. Or your underwear in the dryer on a cold morning. Whoa, I'm ready to go, right? And in about 4 to 5 minutes, you got yourself some perfectly heated, crispy pizza rolls. You're welcome, okay? Now, you don't even have to write that down in your notes because some tips are so awesome, you can't help but remember them. You're going to be a grandparent someday, and you're going to have little ones running around, and they're going to be hungry. Grandpa, Grandma, I want some pizza rolls now. And you're like, oh my gosh, they're going to take 15 minutes in the oven. Wait a minute. Corpy's tip. And then you're a hero to your grandkids. All right? There you go. All right. Okay. All right. Let's move on, shall we? We're on example D, 1D. We've worked with numbers. Now we're going to go a little bit more abstract. We're working with letters. X is a variable. It's our favorite variable in math, right? And it just represents the number. So what I want you to do, quickly, I'm going to give you a minute, is simplify this down to a single power of a single variable. Okay? Go. 1 minute. If you're watching this video at home, you're doing it as well. If you need more time, you can pause it. Y'all can't pause me live, though. Can you simplify it any more than that? Remember, simplifying means not only getting it down possibly to something to a power, but can we write it with fewer things in it? like fewer parentheses or fewer grouping symbols? Is it possible to do that? You okay? You need a mop or something? No? Okay. There's paper towels that will soak up better over there. Okay. Mm-hmm. 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 Yep. Yep. Uh-huh. Yep. Okay. Good. 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 How many terms do we see in Part D?
3.
One. Thank you. Because terms are separated by what? Addition and subtraction symbols. Okay. We have one term here. Remember, if I would say plus 1, now we have 2 terms. Okay. There's only one term. But how many factor groups do we see? We see 3 factor groups. Okay. 1, 2, 3 factor groups. All right. And let's go then through each factor group and see if we can simplify it. Negative x to the 4th. Well, there's a couple of options there. If I take a negative number and I raise it to an even power, is it going to be positive or negative? Positive. It's going to be positive. So I could, if I wanted to, write that as x to the 4th. That's an option that I have, right? There's more than one way to eat a Reese's peanut butter cup. There's more than one way to skin a cat. And there's more than one way to work these problems. Skinning cats? What? You don't have to worry about skinning cats because when you all dissect a cat later on in the year in biology, our school purchases cats pre-skinned. All right? Pre-skinned. Now, if I do that, notice that might mess something up. Because without doing that, I can also notice that each of the 3 factor groups has the exact same base already. You see that? And I might want to get all those guys together. Whereas if I get rid of the negative there, he might not be able to play with the other guys. So this is what we call strategy. You look before you leap, right? You don't just go, cannonball! And then in midair say, crap, there's no water in the pool. Right? Right? So I'm going to hold off on that. I'm going to focus on the middle factor and say raise a power to a power. We get 6 and then negative x to the 5th. So the first factor group and the last factor group, I'm just rewriting. I chose to do that. I could have done it the other way. But now, because they're all in parentheses, they're all the exact same base. So when we're multiplying and the bases are the same, what do we do with the exponents? We don't eve them, we add them. Good. So we get 15. And that right there looks like a pretty good answer, does it not? I like it. But is that the same as this? Would I get the same answer? Y'all are y'all are onto this now that these might not be the same. Before yesterday, y'all might have thought they were the same regardless. But remember, in general, we can't just drop parentheses. If I take a negative number and I raise it to an odd power, will that answer be positive or negative? Negative. So is this equivalent down here on the bottom line? Yes, because this is take that number x, raise it to the 15th power, and then take the opposite of it. Okay? So that is equivalent. That is equivalent. So if this were like a multiple choice question on a test, and you had negative x to the 15th, and that wasn't an answer choice, but this one was, you would know that it's okay to do that. I would not put both of these as an answer choice, okay? Only one of them. And that's what multiple choice is good for. There might be an extra step that I require you to take beyond where you naturally would go working the problem. The free response or the short answer, as soon as you get an answer, you could stop. Like you could have stopped here and got full credit. So as you're working through your worksheets on the multiple choice, make sure that you know how to get the answer that is correct. Okay? And not just like copy it from the key. All right? Cool. Any questions on that? Are there other ways to do it? Yes, but this is how we chose to do it. Okay, letter E. We're trying to write this as a power of a single base. Okay, we have how many terms? One term. How many factor groups? Two. There's something to do on each factor group, so let's go ahead and do that. When you raise a power to a power, you multiply, so that becomes 2 to the 12th times 4 to the 6th. And that should be 8 to the 18th, yes? No. I guarantee if this were a test, there would be an answer choice that has 8 to the 18th. Would you take it? That's a bait answer. I'm fishing. I'm fishing for some people to make a mistake. I got the 8 to the 18th on a hook. You going to bite? You going to take it? I'm going to snag you out of the water and I'm going to say, don't do that. Then I'm going to throw you back in the water. Okay? That's not the answer. That's the bait answer. Okay? So if you go wrong in a way that I think most students will, you're going to find your answer there as an answer choice, and you're not going to know that you're wrong. That's why it comes down to practicing in the worksheets, okay? I cannot do that because the bases aren't the same. I can't combine them at all right? So I have two options here, or three really, four really. I guess I have more than that. I have base 2 and base 4. I can write both of these in terms of base 2, or I can write both of them in terms of base 4, or I can write both of these in terms of some third-party base, like 5 or 7, or I can turn and run. Okay? What do y'all want to do? Turn and run. Okay? That is a natural reaction, and now we respond. Reactions are not necessarily good, but responding is. If you take a medicine and you have a reaction to the medicine, is that good or bad? That's bad. But if you take a medicine and you are responding to the medicine, is that good or bad? That's good. Okay? We want to respond in here because that's a deliberate, conscientious choice. A reaction is your body's physiological response, right? If a giant grizzly bear came at me, my reaction would be to turn and run. But my response would be to try to give it a hug. Yeah, but I make bad decisions, okay? And you don't have to make the same decisions I do, okay? I've always wanted to hug a bear. Okay, even if it kills me. What do y'all want to do? I would probably put it in terms of either base 2 or base 4 because we already have those bases. Let's see if we could use them. Raise your hand if you want to put it in terms of base 2. Okay, raise your hand if you want to put it in terms of base 4. Oh, looks like the 4s win. Okay, it's close. The 4s win by 2 fingers. Okay, let's put it in terms of base 4. So 4 to the 6 is like a Crunchwrap Supreme. It's good to go. Yeah? Crunchwrap Supreme. It's good to go. How am I going to write 2 to the 12th in terms of 4? What's that? Use one of the squares. Brilliant. 12 is an even number, right? So let's write that as 2 to the 2 times 6 power. What's 2 times 6? 12. Well, now I could write that as 2 squared to the 6th power. Yes, yes? Because when you raise a power to a power, you multiply? Uh-huh. And what's 2 squared, everybody? 4. So now I get 4 to the 6 times 4 to the 6. Do you have to show every single one of those steps? Maybe not. Maybe not. I could probably follow it if you went from here to here. Maybe if you skip this step. But here's what I would tell you. When you're working these things out, when in doubt, should you leave it out or not leave it out? Not leave it out. Because this is a new level of math class. I'm not going to be impressed. I did it in my head. I'm not impressed by that. I am more impressed with, can you communicate your results? That's what I want to see. The process itself is really the product that I'm looking for, okay? I want to know your thoughts. So when in doubt, do not leave out a step, okay? Now, 4 to the 6 times 4 to the 6, what is that? 4 to the 12th. Good, 4 to the 12th. And we're done, okay? Now, or are we? Let's say that we get to this same fork, 2 to the 12th times 4 to the 6th. Yogi Berra. Y'all know who Yogi Berra is? Not the guy that stole the Picka baskets, but the baseball player Yogi Berra. He is pretty famous for his quotes and for his baseball playing. He said, when you get to a fork in the road, take it. Okay? And that's what we're going to do. We got to a fork in the road. Base 2 or base 4. We're going to take it. We're going to take both tines, if you will. And seriously, though, if you get to a fork in the road, take it because it may just complete your flatware set at home. All right? Let's go ahead and see if we can write it in terms of base 2. So 2 to the 12th is now like a Crunchwrap Supreme. It's good to go. I am going to write 4 to the 6th as parentheses to the 6th. See that? What did I do with my 4? I got rid of it and I put parentheses there. And guess what I'm going to do with the 4 now? I'm going to write it as 2 squared. Okay? So I got 2 to the 12th times, guess what 2 squared is? 4. But I'm not going to call it 4. I'm going to combine the exponents and call it 2 to the 12th. And now I get 2 to the 24th. Okay? They're both correct, aren't they? They are both correct. I don't care which method you use. Okay? In the case over here that we did first, we actually borrowed. I'm not going to say stole or robbed, but we borrowed a 2 from the 12 that was already there. Yo, 12, can I borrow a 2? Sure. Whereas over here, we took what we already had. We were a 4. We just rewrote ourselves and loaned out that 2. Okay? Either way is correct. If you are doing a problem like this, and it's a test question, and you end up with 4 to the 12th and the answer's not there, are you going to say, crap, I did it incorrectly? No, you're going to be, I know I did it correctly because I've been doing the worksheets, I've been taking good notes, I've been rereading my notes, I've been coming in when I had questions, I've been watching the videos, I thoroughly understand, I'm on top of things, I know I didn't make a careless mistake because I'm responding and I'm very deliberate, so I know that's the right answer. But it's not an answer choice. So you have to then have the confidence to say, Mr. Corpy, you're making me go one step further. And you're going to write this 4 as 2 squared. And then 2 times 12 is 24. So that's what the multiple choice questions are. I might make you go 1 or 2 steps beyond where you would normally stop. Whereas if this were a free response question, you could stop with either one of those or something else that's equivalent and be correct. All right? That's why I test you. That's why I train you in 2 different formats. So take your worksheet seriously. Don't just copy the key. I walked in first period before the bell rung, and guess what I walked into? Because I have duty Thursday morning. There was somebody in first period that was key open in one screen, worksheet open in the other screen, transcribing. And I was like, oh, first week and you're already just flat out copying the key. That's not good. I hope that person makes it. We'll see. They might get caught on a few hooks throughout the year. Okay. Part F. I want you to do this one on your own. I want you to write it as a single power of a single number. On your marks, get sets, go. We have 10 more minutes in this class. Try to work straight down vertically. If you need a new column, go to a new column. Put like a vertical line. Your previous math teacher should have stopped you from working horizontally as soon as they saw it. But it doesn't sometimes happen. So now you break that habit. The only time you should work left to right is if it's two steps. If the very next step is the simplified answer, you could put equals and then you have a nice little equation. If it's a multi-step problem, vertically is the way to go. Where are these twos and threes coming from? Well, it's an expression, so it has to be equivalent all the way through. And if you just start squaring things randomly, it changes its value. We're just trying to simplify it down to one number raised to a power. All right, let's look at it, because some of y'all are getting it, some of y'all are stuck. Remember that if we can write everything as a single power, we can then combine the exponents. I got 49, 9, 7, and 3 as bases. Okay, this is one term. It has 5 factor groups, okay? 5 factor groups. The 49, the 9, the 7 to the 5th, the 7 cubed, and the 3 squared. If it's divided, we still call it a factor, okay? It's multiplication or division. Can I write all of those numbers as a power of a single base? No, because 3 is prime and 7 is prime. So at the very least, I can maybe write both of them as powers of 3 and powers of 7. Okay? Now, you can follow the rules, or you can just kind of do what you've normally done, your intuition. You might say, hey, 9 is the same as 3 squared. Did anyone see that? Okay, so what can we do with the 9 and 3 squared? Cross them out. Okay, it would look like this. When we do that, we say that those factors, are you ready for this? We say that those factors divide out. They divide out to give us 1. In the past, you might have said or might have heard adults say that they canceled. They do not cancel. Okay? The 9 and the 3 squared do not cancel. So don't say they cancel. If you said that in the past, don't say it anymore. Factors divide out, not cancel. They divide out to give you a 1. When can we say cancel? This is canceling. 5 plus negative 5. These cancel to give you 0. Okay? Terms cancel. 5 minus 5. Negative 3 plus 3. Those cancel to give you 0. Terms cancel. Factors don't cancel. They do what? They divide out to give you 1. Okay, so now you might say, hey, 7 to the 5th divided by 7 cubed. There's 5 7s in the top and 3 in the bottom. So, and that leaves us how many in the top? 7 squared. And hey, 49 is actually what? 7 squared also. And so now what's 7 squared times 7 squared? 7 to the 4th. That's one way to do it. If you have a bunch of factors, multiplied or divided, you can actually divide things out. And then you could put what's left in the problem. I'm okay with you doing that. So that would be perfectly fine. And then just make sure when you divide something out, like this right here, this is very important. When I divided out the 7 to the 5th and 7 cubed, I put a 7 squared as the residual right there above it. Okay, now that's one way to do it. Here's another way to do it. All right, if you want to do it this way, you could say that that's 7 squared times 3 squared times 7 to the 5th, all over 7 cubed times 3 squared. And now, what happens to the 3 squareds? They divide out. I heard a little whisper of a k over here. But stop. They're about to say cancel, but right? Okay, they divide out. Now, you can use the rules of exponent. Let's go over this. When you are multiplying and the bases are the same, what do you do with the exponents? You add them. So we get 7 to the 2 plus 5, which is 7. And now it's divided by 7 cubed. Now we haven't done this one yet, but here we go. When you are dividing and the bases are the same, what do you do with the exponents? You subtract them. So that's 7 to the, I'm going to write this as an intermediate step just for educational purposes. You subtract 7 minus 3, which of course is 4. Okay? Yay. Yay. Now, what if you're like, Mr. Corpy, I don't like subtraction. It's a negative thing, and my family, we believe in no subtraction. I'm like, that's okay. You don't have to subtract, okay? Here's what you could have done instead of subtracting. You could bring this factor, which is 7 to the 3rd, you could bring it to the top, okay? As long as you do what to its exponent? Y'all remember? You change the sign. Very good. That's another property of exponents. You can bring a factor that's multiplied or divided from the top to the bottom or the bottom to the top. It doesn't really matter as long as you change the sign of the exponent. If it's positive, now it's negative. If it's negative, now it's positive. And now, because I'm multiplying, what do I do with the exponents? I don't subtract them, I add them. So what is 7 plus negative 3? It's still 4. But now we didn't subtract. We added the opposite. We get the same answer. Okay? In the few minutes that remain, let's just summarize some of these rules, okay? This is an important part of the notes because we're summarizing what we've been doing. When you're multiplying and the bases are the same, what do you do with the exponents? You add them, and there's an example right there. When you're dividing and the bases are the same, what do? You subtract the exponents, and there's an example. Here's a nice little fact. What's anything to the 0 power? 1. What's 5 to the 0 power? 1. What's 2/3 to the 0 power? 1. Now that's true for everything except 0. 0 to the 0th power might be 1, but it also might be 7 or negative 3 or 28. That's an indeterminate form that we'll talk about in calculus. And then the last one we'll summarize for the day. When you raise a power to a power, what do you do with the exponents? You multiply them. Okay, we'll continue with the notes tomorrow. The worksheet's not due tomorrow, but the worksheet is out there. It awaits you. It wants you. Okay, get to know it. Practice, practice, practice. And remember, you also are reading the parent letter, the student letter, and filling out the surveys. Okay? Tomorrow is Friday. It's all white Pride Day. So make sure that you wear as much white as you possibly can.